Students, welcome to Comfort Physics classes. This is your tutor Dr. Sivakumar here to tute physics. Today we are going to discuss about the topic electric potential at any general point due to an electric dipole. We know that the negative and positive charges are separated by a small distance constitute an electric dipole with the distance 2a between the charges. Now we are going to consider a point P is at a distance R1 and R2 from the positive charge as well as the negative charge. So from the point, that is from the midpoint O to the point P, the distance is R. Therefore here POB will have an angle theta. Therefore the angle POA becomes 180 minus theta. Already we have discussed about the electric potential at particular point. Here say the point is P due to positive charge is 1 by 4 pi epsilon naught q by R1. Similarly for the negative charge it becomes minus 1 by 4 pi epsilon naught q by R2. So the total potential at point P is due to sum of these two charges, that is V is equal to 1 by 4 pi epsilon naught q into 1 by R1 minus 1 by R2. Let us consider this as equation number 1. Then apply the cosine law for the triangle BOP. Therefore R1 square, which is equal to R square plus A square minus 2RA cos theta. Here I am going to take R square as a common factor outside. So it becomes R square into 1 plus A square by R square minus 2A by R into cos theta. Let us consider the point P is very far away from the dipole. Therefore when compared to the distance A, the distance R is very maximum. Therefore A can be neglected. So the A square by R square term will be neglected from the above equation. Therefore the above equation becomes R1 square, which is equal to R square 1 minus 2A cos theta by R. Let us consider this as equation number 2. You take square root on both sides of the equation number 2. Therefore the above equation becomes now R1 is equal to R into 1 minus 2A divided by R cos theta power 1 by 2. Let us consider this as equation number 3. So now we are going to use a binomial theorem to get the perfect form. So here the power will be getting inside. So here the red mark represents that we are going to bring this minus 1 by 2, that is power value, to inside of the bracket value. Okay, so 1 by R1, which is equal to 1 by R, 1 minus within a bracket minus 1 by 2 into 2A by R into cos theta. So minus will get plus, then 2 will be getting cancelled. Therefore the equation becomes 1 by R1, which is equal to 1 by R, 1 plus A by R cos theta. Let us consider this as equation number 4. Similarly, apply the cosine law for the triangle, that is left side triangle AOP. Then similarly one can able to get the value for R2, that is R2 square is equal to R square plus A square minus 2RA cos theta. Here instead of theta it is 180 minus theta. And we know that according to the trigonometry theorem, 180 minus, that is cos 180 minus theta, which is equal to minus cos theta. Therefore replace the above factor by minus cos theta. Then the above equation becomes R2 square is equal to R square plus A square plus 2RA cos theta. Okay, now we are going to take this R square term as common as we discussed earlier, and we are going to neglect the R square and the A square by R square term. Therefore the final equation becomes R2 square is equal to R square 1 plus 2A cos theta by R. Take square root on both sides, it becomes R2 is equal to R into 1 plus 2A cos theta by R whole power 1 by 2. Then here also we need to apply the binomial theorem as we discussed for the equation number 4. So take the power value inside of the bracket value, then it becomes 1 by R2, which is equal to 1 by R, 1 minus A cos theta by R. Let us consider this as equation number 5. So whatever we have done for R1, the opposite manner, just to replace the positive as negative, then the equation for R2 becomes 1 by R2 is equal to 1 by R, 1 minus A cos theta by R. So one can able to compare. In the equation number 4 it is 1 plus A by R cos theta, here 1 minus A by R cos theta. So we need to substitute these two equations 4 and 5 in equation number 1. Therefore equation number 1 becomes 1 by 4 pi epsilon naught q into within a bracket 1 by r, then 1 plus a cos theta by r minus 1 by r 1 minus a cos theta by r. So we need to rearrange the terms. So that is 1 by r 1 plus a cos theta by r minus 1. We are taking 1 by r as common. We take it outside. Therefore minus 1 plus 1 will be getting cancelled. So a cos theta by r, again 1 a cos theta by r. Therefore it becomes 2a cos theta by r. So 2a q by r square into cos theta. We know that the electric dipole moment P is equal to 2qa. Therefore the above equation becomes V is equal to 1 by 4 pi epsilon naught P cos theta by r square. Let us consider this as equation number 7. So this is the final equation. As we discussed in the trigonometry section, here the formula for a vector dot b vector is equal to ab cos theta. Therefore here one can able to write this p cos theta as p vector dot r vector. Here r, instead of r vector we have r cap. R cap value is 1. Therefore the formula becomes only p cos theta. Instead of p r cos theta, it becomes only p cos theta. So the above equation can be written as V is equal to 1 by 4 pi epsilon naught p vector dot r cap divided by r square. Okay. So anyway, you follow only equation number 7. We have some special cases. Case 1. If theta is equal to 0, that is, if you are considering a point P along the dipole axis, then theta is equal to 0. Therefore the above formula becomes, that is cos 0 is equal to 1. Therefore V is equal to 1 by 4 pi epsilon naught p by r square. Case number 2. The point P lies on the axial line of the dipole on the side of negative, that is negative charge, minus q. Then theta is equal to 180. If you are considering along the positive charge, theta is equal to 0. If you are considering along the negative charge, then theta becomes 180 degree. Therefore cos 180 is minus 1. Therefore the formula becomes V is equal to minus 1 by 4 pi naught p by r square. Case number 3. The point P lies on the equatorial of dipole. That is, in theta is equal to 90. Cos 90 is 0. Therefore the total voltage becomes 0. Thank you students. We'll discuss electric flux in the next video. Thank you.